This video will look at hypothesis testing, and in this case we'll work on an example with a small sample size. Example 2. A high school counselor wishes to test his theory that the average number of dropouts in the district is 21. He reviews the data for the last 17 years and finds the mean number of dropouts is 18.7. At alpha equals 0.05 is the theory correct. The standard deviation for the sample is 1.5. Okay, so the first thing we need to do is set up our hypotheses. And in this case, the counselor simply said that he thought that the average was 21. So our null hypothesis is mu equals 21. Our alternative is mu does not equal 21. Okay, so we get through that step. Now, in order to do steps 2 and 3, what we need to do is we need to determine which test to use. And remember that we prefer the z-test because z has a smaller variance than t. But in order to use z, we either have to know the population standard deviation or we have to have a large sample. In this case, we know a standard deviation, but it's the sample. So we don't pass on that one, and our sample is only 17 data points. So we don't qualify on either one. So we need to resort to the t version of the formula. So when we do that, first thing we have to do is find the critical values. And when it's a t-test, we know alpha, 0.05 from the problem. This is a two-tailed test because our null hypothesis is equal, our alternative is not equal. So we can reject if it's low or high. A little bit later, we'll see some one-tailed examples. Okay, the degrees of freedom is equal to the sample size minus 1. So 17 minus 1, 16 degrees of freedom. If you go to your t-table or if you utilize Excel, 16 degrees of freedom, alpha equals 0.05, two-tailed test, your critical values are plus or minus 2.120. So if we're below negative 2.120 or above positive 2.120, we'll reject the null hypothesis. Now our test statistic. This is very similar to what we did with z. Instead of z, we have t. Same thing, test statistic. The numerator is the same. X over bar, sample mean, minus mu, population mean. Denominator, we have s over the square root of n. S is still standard deviation, just in this case it's sample standard deviation. N is still the sample size. So we plug the 18.7 and 21 into the numerator, 1.5 for the standard deviation, 17 for the sample size. Do the square root and the subtraction. I'm working concurrently in the numerator denominator. Do the division in the denominator, and then finally do the overall division. And when I do, I get a test value of minus 6.322. Now that is well below negative 2.120, so we're in the reject region. So we reject the null hypothesis. Based on rejecting the null hypothesis, which was mu equals 21, our conclusion is the actual average is probably different from 21. If we wanted to find the p-value, we would do that by using, in Excel, we could use the t.dist.2t for two-tailed formula. You need to use the positive number of your test statistic, 6.322, and your degrees of freedom. It kicks out a number. When you see this e to the negative 5, that's scientific notation. That negative 5 tells us we need to move the decimal place 5 to the left. So we go 1, 2, 3, 4, 5.